Okay, the directions say to circle yes or no as to whether each trinomial is a perfect square. If so, you factor it. If not, you explain why it's not. To be a perfect square trinomial, you need to be able to take the square root of the first term, the square root of the last term, multiply the two answers together, double it, and get the middle term. If you can't do that, it's not a perfect square trinomial. So in front of 1x squared is a 1, so you're asking yourself, can I do the square root of 1? 25 is the last term. Can I do the square root of 25? Well, square root of 1 is 1. Square root of 25 is 5. If I do 1 times 5, I get 5. And then I have to double it. Do I get the number in the middle? Well, 5 times 2 doubled is 10, so it did factor. Then you can think of it in terms of the Korean method, if that helps you. But x squared gets split into x and x. The square root of 25 was 5. So 5 times 5 is 25. Since my middle term is plus, then I know that when I multiply, I have to have the same signs to get the positive 25, and they had to both be plus to get be a positive 10. Or you could have just written it as x plus 5 squared. That's what makes it a perfect square trinomial, is you have the same set of parentheses repeated. Okay, what about number 2? Well, 36, can I do the square root of 36? Yes, I get 6. Can I do the square root of 4? Yes, I get 2. If I multiply those together, I get 12, then I have to double it. So I get 24. Is 24 the number in the middle? No. So I would circle no, and I would say if I do 6 times 2 doubled, it's not 24. That's how I know it's not a perfect square trinomial. Oh, and this one was, so you had to circle yes. Okay, a difference, number 3 says determine whether each binomial is a difference of two squares. The format for a difference of two squares is a squared minus b squared factors into a minus b times a plus b. So you have to ask yourself, do I have two terms? Yes. Is it subtraction? In other words, difference? Yes. Can I do the square roots? So can I do the square root of 1? Can I do the square root of 12, or square root of 144? Yes, I get a 1, I get a 12. So it is a difference of two squares, so the answer was yes. And I can factor it into x and x. 12 times 12 is 144, but to multiply to get a negative 144, the signs have to be different. Okay, number 4, can I do the square root of 9? Can I do the square root of 21? Well, I can get 3, but I can't do the square root of 21, because if I did 4 times 4, I would get 16. 5 times 5, I would get 25. And 21's in the middle, though, so it won't work. So this one's no. And I would say because 21 is not a perfect square. I can't do the square root of it. If you can't do the square root of it and come out with a whole number, it's not a perfect square. Okay, number 5. Well, it's got two terms, but it doesn't have a minus sign. So it doesn't meet the fact that it's a difference of two squares. That's a sum of two squares. You can't factor the sum of two squares. So you say no. Okay, circle yes or no as to whether each polynomial is completely factored. If not, factor it. So basically you're looking inside the parentheses to make sure that it can't be factored again. First question you always ask yourself, is there a GCF? Well, between 3, 7, and 2 it's just a 1, so I would say no. But this is a trinomial. Trinomials are the kind that you try the Korean method, so I've got to double check and make sure that I can't factor it. So 3 can be 3 times 1. 2 can be 2 times 1. So that would be a 3, that would be a 2, 3 plus 2 is 5, so it didn't work that way. So then I go back, maybe I can switch the 1 and the 2 around. That was my only choice to multiply to get 2. So if I switch around my 1 and my 2, 1 times 1 is 1, 3 times 2 is 6, 1 plus 6 is 7. It did work. So I can factor that set of parentheses into a 3x and an x, because I can put my x's here. Go straight across. That would be 3x plus 1, and this would be 1x plus 6. But you can't forget that there was this 2 on the front, so you got to put him back as part of your answer. Now it's completely factored because 3x plus 1 doesn't have a greatest common factor, and x plus 6 does not have a greatest common factor. And since they're binomials, the only other way to factor a binomial would be difference of two squares, and those are not squares. Okay, number 7, n plus 5 times 4n minus 10. Well, n plus 5 I can't do anything to, but 4n minus 10 has a common factor of 2. So I can divide out the 2 and say that's 2 and then 2n minus 5. But you can't forget about that n plus 5, so you got to put that back on the end as well. So it was not completely factored. And 2n plus 5 just has a GCF of 1. N plus 5 has a GCF of 1. They're not the special case difference of two squares, so I'm completely factored now.